Okay, let's get started. Today we'll be doing section 4.1. This is the first part of that section. The section is called Systems of Equations. So what we'll be dealing with in this section are linear equations, and we have three possibilities with linear equations. These will be two equations with two variables each. So when you graph two lines, here are the possibilities. You might have a line and another line, and those lines somewhere in space intersect at a point. Whatever that point is, this has one solution. The solution is the point of intersection. So the solution is the point that satisfies both equations. It's where they intersect. Okay, so that's the first case. This is the one that actually comes up most frequently. Then you can also have lines that are parallel. So I'm going to do my best here to draw parallel lines. So imagine that they're parallel. And if they're parallel, the solution is their intersection points. So how many intersection points would parallel lines have? Well, none, right? So this has no solution, no value, no coordinate xy point that would work for both equations. In my MATLAB notes, they have indicated that with the empty set. So we will follow that custom. Okay, the final possibility is that when you graph a line and then you graph the second line, that the second line actually lands on top of, it's the same line as the first line. They're the same line. And if that's the case, then any point on the line, any point on one of the lines is also on the other line, right? So any point on the line is a solution. Now, in my MATLAB notes, these lines will have equations, like the line equation might be y equals 3x plus 1, something like that, okay? And then the way they're going to write the solution set is they're going to say the set of all xy points, tip my camera there, where they satisfy this equation, like that, okay? And so this is the way they're going to write it in my MATLAB. I presume that may be the way they put it on my MATLAB. Well, this is the way they do it on the lecture notes, and I presume it may be the way they do it in my MATLAB, but we'll find that out with the homework, right? So these are the three cases, and again, this is the one that you're going to see most frequently. So the first set of problems in this set of lecture notes says, number 1A, determine whether the given ordered pair is a solution to the system of equations. So they've given us a system of equations, which means two lines in this case. Here's one line, and we could graph that if we wanted, but they didn't ask us to. And here's the other line. And they want to know if the point 3, 1 is a solution. Now remember that a solution means that that is the intersection point. If it is the intersection point, then this xy could be plugged into both of these and it would satisfy those equations. So let's put 3 in for x and 1 in for y, and we get 4 equals to 4. So we say, yes, that point satisfies this one. So I know this point is on this line. Now the question is it on this line? Let's check it out. We'll put the same 3 in for x and the same 1 in for y, and we get 2 equals to 2. So when you graph this, this is the line where, this is the point where those two lines will intersect, okay? So yes, it is a solution. It satisfied both, yes. Okay, let's do part B, the same thing. 1B. And again, it's asking about, this time, the point -6, 4. Remember, this is my x and my y that we're checking if this is the solution point. And the equations that they're giving us, the first line is y is equal to 4. And the next equation says x is equal to negative, put a negative there, 3y. Okay, so is y equal to 4? Yes. because the y value is 4, so you could put it in there if you wanted. 4 is equal to 4, yes. Now over here we know the x should be negative 6, and the y is given to be a 4. So we have negative 6 is equal to negative 12. No, that point is not on this line, therefore it's not the intersection point. So no, not a solution. That point is not the intersection point of the two lines. We don't know if they have one or not, we just know that that point is not it. Okay, let's go to part C, the same type question, and you'll have one of these show up, no doubt, on your next test. This says to check the point 1/2, comma 3. All right, and the two lines that we're supposed to check are 2x plus y equals 4 and negative 3x equals 2y plus 8. Okay, no problem. So I'm going to change all the x's to 1/2 and all the y's to 3 and see if they equal. So I take 2 times 1/2 plus 3 equals 4. Let's see. 2, that's 2 over 2, which is 1 plus 3 equals 4. So I get 4 equals 4. So far, so good. This point is on that line. Okay, now let's check it over here. Now we put the x in, put a 1/2 here. 2 times the y, which is 3, plus 8. So I get negative 3/2 equals, that's not going to be 3/2, but let's go ahead and work it out. 6 plus 8 is 14, right? No. So it is not a solution. It is not on both of those lines. It's not on this line at all. Okay, so it can't be an intersection point or a solution. Okay, so now let's look at graphically what we're doing here. The first way to solve systems of equations, there will be 3 ways to solve systems of linear equations. And the first way is graphing. It's not the most efficient way to do it, but it's the best in terms of seeing what's going on and understanding the picture. So the first problem that they ask us to do, number 2a, it says to solve this system by graphing it. And it gives you x plus y equals 4 and x minus y equals 2. So what they're saying is, do these two lines intersect? And if so, where? And they want you to solve that by graphing the lines. So the first thing I would do is I would take this line and I would go over to the side and I would say that is y is equal to, subtract the x on both sides, negative x plus 4. So I now have a slope-intercept form and I'm going to graph that line. Okay. Then the next thing I need to do is take this line and I think I'll move the y over on it. So I'm going to move the y over to this side to make it be a positive y, add y, and then I'll leave the x and subtract 2. So here's the other one. Let's write it this way to look better, x minus 2. Okay, so here's the second line solved for y. These are in slope-intercept form. You'll remember that the number in front of the x is a slope, and this is the y-intercept. So I used that information to get a quick graph of these, and I went ahead and graphed it before I started recording the lecture today. And here is the way this graph looks. So let me see if I can get these both on the camera at the same time. Okay, so this first one had a slope of intercept of positive 4. So I said it intercepts here at 4, and it has a slope of negative 1. So it goes down 1, right 1, down 1, right 1. So it's going to cross over here at positive 4, 1, 2, 3, 4, because if I put a positive 4 into here, negative 4 plus 4 would make a 0. So that pink line is this first one. Kind of the red and the pink go together. And then I said this one intersects at negative 2. Its intercept of the y-axis is at negative 2. It has a slope of positive 1. So it goes up 1 over 1, up 1 over 1, up 1 over 1. I drew a few more points. And I want to check that the intercept here is at 2. So I put a 2 in here. When x is 2, we get 2 minus 2 is 0, y is 0. So that looks good. And I drew this, and lo and behold, they did intersect, and it looked quite clear that they intersected at the point 3, 1. Now, if I wasn't sure of that, I would simply go in here and say, if x is 3, right? We get negative 3 plus 4, which is 1. Y would be 1, and it checks out over here. And I'm putting 3, 1 in here for x and y, so I put the 3 in here and the 1 in there. 3 minus 2 is 1 equals 1, yes, okay? So I verify it algebraically once I've drawn the graph and I can see where they intersect, okay? So again, remember that the beauty of these recorded lectures is you can pause and go back and look at this again if that is helpful. So I'm moving on to part B now on question number 2. Okay, 2B. Now they would like us by graphing to work with the line. Now I'm going to write these separate so I'll have a little more room to work. 2x plus 4y equals 10. And the other one I'm going to go down a little way on the page is 4x plus 3y equals 10. We're supposed to find out by graphing if these have a solution, an intersection point or points as it would be. So I'm going to solve this for y. So I'll say 4y is equal to, bring that over, negative 2x plus 10. Now I'm going to divide everything by 4. And I will get y is equal to negative 2 divided by 4 is 2/4, which is 1/2. Go ahead and show that middle step if it's helpful to you. And then this is 10 divided by 4. 2 will divide into that. It reduces to 5/2. So the first line is at negative 1/2, 5/2. So I made a little table for that. That's not the greatest thing to graph. And I said, well, what if I let x be negative 1, then I would have a negative 1/2 times a 1, which would be a positive 1/2. 1/2 plus 5/2 is 6/2, and 6/2 is the same as 3, okay? And you may want to write down those middle steps instead of just doing it in your head. Now let's put a positive 1 in for x. So 1 times 1, negative 1/2 is a negative 1/2. Negative 1/2 plus 5/2 is 4/2. 4/2 is the same as 2. And finally, I'm going to let x be, of all things, 5. And I'm doing that because I know that's going to give me the intercept, because I'll get a negative 5/2 and a positive 5/2, which makes a 0, and that's great for graphing. So I'm going to go ahead and put this on my graph by plotting those points in just a minute. You can see over, let me fold it up and move it over here. Well, I'll show you the graph in a minute. Let's graph the other one first. Let's plot it out. So we're going to leave the 3y over here and subtract 4x on both sides. And then I'm going to divide the 3 off to get it in intercept form. Negative 4/3 x plus 10/3. Ugly. Okay. And now I'm going to make some points on this line, and I didn't pick the greatest values. I let x be 1 first. And so I get 1 times negative 4/3 is negative 4/3. Negative 4/3 plus 10/3 makes 6/3. 6/3 is the same as 2. Ah ha ha ha, we're in luck, folks. Look, we already at least have 1 point that's the same. We have to find out if there are more. So then I'm going to let x be 0. And it's not going to be very pretty, but why not? That makes this go away, 0. And we have 10/3, which won't be the best thing to graph, but oh well. And let's put a negative 1 in now. So negative 1 times negative 4/3 makes a positive 4/3. Positive 4/3 plus 10/3 is 14/3. Ugh. Which is, yeah, okay. So we're going to graph that. 3 goes into there 4 times 12, 4 2/3, something like that. Yeah. Okay, so let's go to the graph and graph this thing up. And you will see that I've already done this. Let me fold this down so we can get it where we need it here. Okay, this first line I did in brown, and I put the point 1, 2, negative 1, 3, and 5, 0, and I drew the brown line in here. And notice they only had that 1 point the same, right? Because when I put negative 1 in, I didn't get the same y out. So they're not parallel, or they're not the same line. Well, they would have to be the same line. They're not the same line. Okay, so I plotted these points. I had 1, 2, and then I said it's going to cross at about 10/3, which is about 3 1/3. So I went up 1, 2, 3 1/3 and put a dot close enough. And then I went over to the right. Well, At -1 it was, I think I actually put in another point over here, but anyway, right down here. It crossed at, then I let y be 0 maybe. When you let y be 0, yeah, I got the intersection point here at 5/2. So there's my second line, but that accuracy isn't terribly important because we have the intersection point here at 1, 2. So this is the solution. The solution is that intersection point, and we got it by graphing these, okay? Actually, by making the table, we got it, okay? And let's move to the last one of this type. And it asks us, this would be part C. Okay, 2C says y is equal to -x plus 3. And the other line is 2x plus 2y equals -1. Okay, so let me solve this for y. -2x minus 1. Divide the 2 off. That would be a -1. 2 divided by 2 is 1, and it's a negative there. -x, we don't really need the 1. Minus 1/2. Ugh. Y equals -x minus 1/2. So my lines are -x minus 1/2 and -x plus 3. So notice that these have the same slope. Things that have the same slope, automatically in your head you should think parallel. Anything with the same slope is parallel. Notice that these have different intercepts. So once we put those on a graph, and I've gone ahead to do this a little before we started, and this one that says x plus 3 intercepts up here at 3 and over here at 3, and this intercepts at -1/2 on the y-axis and -1/2 on the x-axis, and these have a slope of -1, and they're in fact parallel, which means they have no solution. Okay, so that's good. I kind of wish they'd given us the last case, but they didn't, okay? And that would, the last case would be if we drew one of these lines and then drew the next one and it landed right on top of the one we already had. So, no problem there. Okay, that concludes part 1 of this section. I'll be back in just a few minutes for the second part. See you then.